You're probably getting tired of this limit process, and I promise that we won't have to use it for much longer. But here, to find the derivative, we want to find the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Here we do have a little bit of extra work because in our function there's an x squared and a minus 5x. So when we make this substitution, we have the x plus delta x squared minus 5x plus delta x. This is going to simplify to x squared plus 2x delta x plus delta x squared minus 5x minus 5 delta x. So now let's go back to our derivative and evaluate this limit. We'll have x squared plus 2x delta x plus delta x squared minus 5x minus 5 delta x. We subtract the function, and I'm just going to remember that I need to subtract all the way through, which means I'm going to change all of the signs. Then all of this is over delta x. We still keep our limit because we have not evaluated yet, but we can do some simplifying, and you should be left with only terms that still have delta x in them. The last step here is always the same. You factor out the delta x. So I have delta x, and this is 2x plus delta x minus 5 divided by delta x. Those delta x's cancel. I can now evaluate. The delta x is going to go to 0. So now my derivative, f prime of x, is equal to 2x minus 5.